Okay, now we're going to look at uniform motion problems, and these are kind of tricky. So just bear with it, and it might take some more practice than you um, needed for the other things. So this is page 51 in your workbook. It starts with opposite directions. So I'm going to go through some different types, but the basis is that we need to look at RT equals D, or a lot of times people call it the dirt ones, D equals RT, and D is our distance, R is our rate, so it's going to be in usually miles per hour for these, but that could vary. And then time is our time in usually hours, but you've got to watch for that too to see what the units are. So when we're looking at opposite directions, we usually have like our point A and our point B, and someone's traveling, say, to the east, and someone else is traveling. They might go a little slower, like they're the slow car, and then the fast car leaves at the same time, and then they meet. Hopefully, they don't crash. They're on opposite sides of the road. So let's read through the problem. One car, and we'll call that one A, is 60 miles from another car, B. If car A, we'll read through the problem in full first, and then we'll start marking stuff up. If car A begins driving towards car B at a rate of 20 miles per hour, at the same time, car B begins driving towards car A at a rate of 25 miles per hour. How long will it be before the automobiles meet? So we're trying to find time. So it would be in hours. So let T equal time in hours, and that's to meet, right? So car A is going along, and car B is going the other way, and they're going to meet at some point. And we know the total distance is 60 miles. So that is D. So we want to track that. So I'm going to write that out. We also want to track up here that car A is going at a rate of 20 miles per hour, and car B is going, so this is, car B is going at 25 miles per hour. So that one's a little faster. So if we know that the total distance is 60, we can say, this is our a little phrase, the distance for A plus the distance for B equals total distance. To find distance for A, we would do the rate of A times the time of A. Okay, same here. Rate of B times the time of B equals total distance. So we don't know the time for A, and we don't know the time for B, but we do know that they're the same. Time for A equals time for B, so we're just going to call it all that T, because it's happening all simultaneously. So then we're going to go ahead and write our equation. So we would have our rate 20t plus 25t equals D. And add those together, we get 45t equals D. But we need one more number in there. I forgot to write that our D is 60. So if you notice, oh, I got too many variables going on here. That's because I just forgot to set something in. So now we're going to divide by 45, and we end up with T equals 1 1/3 hours. Okay, you just reduce that to 4/3, but we don't usually say 4/3 hours. So I know I a lot of times wanted you to keep things as improper fractions, but for word problems, that's usually the other way around. A mixed number or decimal is good. And if we can keep it to having non-terminated things, like 1/3 is a lot more precise than zero point 0.3 or 0.333, it doesn't terminate. But if you want to gauge, you could say about 1.33 hours. Better yet, you could take that third of an hour if you think of a clock, right? A third of an hour is going to be 20 minutes. So for my sentence, let's see, I might want to say something like, it took 1 hour, 20 minutes, although 1 1/3 hours is usually fine unless I ask specifically to split it up, for the cars to meet. Okay, so hopefully that helps you to learn the patterns, like if they're coming towards each other. This is very systematic type problem, but I like you to apply principles more than just like parroting it back. So I do give you a variety of choice, but then you have to think, how can I piece a problem together? And that's a really awesome skill to have. So keep trying that and not necessarily looking back like, oh, what problem, what's an exact match, and just cutting and pasting numbers and things like that. But trying to take an approach of figuring it out, like how I talked through it with you. So now we're on example 4.19. A motorboat leaves a harbor and travels at an average speed of 15 miles per hour toward an island. The average speed on the return trip was 10 miles per hour, probably because there was some current or whatever. How far was the island from the harbor if the total trip took 5 hours? So again, we have the same sort of idea. We're going to use that rate times time equals distance, or vice versa. And we have to look at what we're given and what we're trying to find. So a lot of times I just look at what we're trying to find. So how far was the island? So let D equal distance, and that's the one way, from harbor to island. Okay, so we're tracking that. So we don't know that. We do know that the from the harbor, I'll call that H, to the island. Okay, and here's our harbor, has like some docks on there. Maybe here's my sailboat, which does not go 15 miles per hour. No, wouldn't even go 10. So we know that's a certain distance that we're trying to find. We know that we traveled 15 was our rate. And we know that the total trip took 5 hours. What we don't know is like which piece was which, right? So we have to say that T, will set one equal to the time from harbor to island. Let T equal time in hours from H to I. Okay, so that was 15T, and that equals the total distance also. So we're kind of tracking that. Equals distance one way, right? Then we also can look at this value that it took 10 miles per hour at a certain amount of time to return. And that also equals D. But how do we know what the t is? So we're going to set that up. If t is the time to get there and it took 5 hours total, it's just like your other things. When you have money, you have a total amount of money and you subtract it off the X dollars put into your account. This is the same thing. We had a total of 5 hours and we're subtracting off the time it took to get out to the island is the time to get back. Okay, island to harbor. Okay, so that's our return trip is this info here. So we can substitute that in. We can write 5 minus t, and that'll give us our distance. It's the same, right? So distance from harbor to island equals the distance from island to harbor. It's the same distance. So those are going to be equal to each other. Okay, harbor to island, island to harbor. So we established that those are equal. Now we can take these expressions. So if it's 15t can represent the distance, the rate times time, remember is distance for the one way. Then on the way back, which was my slower pace, at whatever time that took, 5 minus t, then I know they're equal. So now I can solve. So I'm going to set it up as, that's part A here. If I'm writing out my steps, C is solving. So I have 15t equals 50 minus 10t. Then I'm going to add 10t to both sides. So I get 25t equals 50. Divide both sides by 25. I get t equals 2. Now that represents the distance or the time, right? 2 hours that it took. So it took 2 hours to get to island, and then it took 3 hours, because remember that has to total 5 hours to get back. But that's not our question, right? It wants to know how far is that harbor. So we can figure that out because we said, okay, one way is 15t. We can just pop it into either expression actually, but I'm going to do the easier one. So I would say if it took 2 hours here for t, I can just put that in 15t. So therefore, distance equals 15 times the 2, 30 miles one way. So that's my answer. I'm going to write down here. The island is 30 miles from the harbor. Now that might take a little getting used to of how to piece those together and like how, oh, do we really even need to know time? A lot of times people will just give me, oh, t equals 2, but you'll lose a point because you didn't answer the full question. And so we really need to pay attention to what we're being given, how it's laid out, how they relate to one another, and then what are we trying to find, right? So our overall thing is to find distance one way. So I hope you found that helpful. I'm going to end this video and do a couple more problems, hopefully walking you through some different situations, and you could try doing some classwork on that too. So have a great day. And if you have questions, you can either email me or pop it in the comments of the assignment box. But if you write it right on your work, I may not see it right away, but comments I get sent directly to my email, and I can help you out or clarify something. It's always good to know. And we could even do a Zoom or something. So That's it for now.